Hello and welcome to yet another video of Cornerstones of Math. Today we are going to rationalize the denominators of these two fractions, 1 over 4th root of 7 plus square root of 2 and 1 over 5th root of 3 minus 1. And without further ado, let's jump right into it. So the basic idea for rationalization is to multiply the expressions having opposite signs on both denominator and numerator. In that way, the terms in the denominator become the squares of something, which may be free of radicals. But as for our case, we have the 4th root radical in the denominator, and because of that, there are two formulas we can use for this problem. The first formula is this basic square minus square formula I just mentioned. So let us multiply 4th root of 7 minus square root of 2 on both denominator and numerator. Then we have 4th root of 7 minus square root of 2 divided by 4th root of 7 squared minus square root of 2 squared. And this 4th root of 7 squared is equal to square root of 7. If you're confused, then using fractional exponents might help. So we have square root of 7 minus 2 here. And this is the type we encountered many times in the textbook. We just multiply square root of 7 plus 2 on both denominator and numerator. Then we have 7 minus 4 at the denominator, and on the numerator, first we have 4th root of 7 times square root of 7, and square root of 7 can be also written as 4th root of 7 squared, then minus square root of 7 square root of 2, then plus 2 times 4th root of 7, and then minus 2 square root of 2. And this part equals 4th root of 7 cubed, which equals 4th root of 343. So we have this minus square root of 14 plus 2 times 4th root of 7 minus 2 square root of 2 divided by 3. But we can use another formula which allows us to rationalize the denominator in a single step. That is, we use this rather unfamiliar factorization formula for a to the power of 4 minus b to the power of 4. You can obtain this by either using the factor theorem or using this rather easy factorization of a to the power of 4 minus b to the power of 4 and expanding this part. Anyway, to apply this formula, we must multiply 4th root of 7 cubed minus 4th root of 7 squared times square root of 2 plus 4th root of 7 and square root of 2 squared here and minus square root of 2 cubed, and same goes here. This makes the denominator 4th root of 7 to the power of 4 minus square root of 2 to the power of 4, which is 7 minus 2 squared, hence 3. And on the numerator, 4th root of 7 cubed and 4th root of 7 squared equals square root of 7, and square root of 2 squared equals 2, and square root of 2 cubed equals 2 square root of 2. So we have 4th root of 343 minus square root of 14 plus 2 4th root of 7 minus 2 square root of 2 over 3. Now the second one. Here, let me introduce the general formula first, which is this. This is really easy to obtain, by the way, by realizing that a to the power of n minus b to the power of n always has a factor a minus b, and the simple polynomial division gives this part as a quotient. In our problem, we have 5th root radical, so we are going to use the formula when n equals 5, which is a to the power of 5 minus b to the power of 5 equals a minus b times a to the power of 4 plus a cubed b plus a squared b squared plus ab cubed plus b to the power of 4. And to simplify even more, we substitute b with 1, which gives a to the power 5 minus 1 equals a minus 1 times a to the power 4 plus a cubed plus a square plus a plus 1. Therefore, the basic idea is that we multiply this thing on both denominator and numerator. For our specific case, a is equal to 5th root of 3, so we multiply this. Then we know that the denominator equals 3 minus 1, which is 2. And on the numerator, we have 5th root of 81 plus 5th root of 27 plus 5th root of 9 plus 5th root of 3 plus 1. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.